Yeah, it has started streaming also. A very warm good morning to all of you. I, Dr. Neelam Chaplut, Associate Professor, Purnima College of Engineering, feels immense pleasure to extend warm welcome to all eminent guests and delegates on second day of Faculty Development Program, Trends and Application in Machine Learning and Deep Learning, being organized by Computer Science Department, Purnima College of Engineering, sponsored by Rajasthan Technical University under TechUp 3. I welcome our expert, Mr. Akshat Gupta, Machine Learning Engineer, Nivea Life Care, Dr. Surendra Kumar Yadav, Head of the Department, Computer Engineering Department, Purnima College of Engineering, Dr. Praveen Gupta, Professor, Purnima College of Engineering. Today is 5th September, that's Teachers' Day. I think this day cannot be celebrated in a better way than the way we are celebrating with the galaxy of teachers in the form of experts and participants. Wishing you all a very happy Teachers' Day. In India, Teachers' Day is celebrated annually on September 5th to mark the birthday of our Honorable former President, scholar, philosopher, and Bharat Ratna awardee, Dr. Sarvapalli Radhakrishnan, who was born on this date in 1888. Dr. Radhakrishnan was the first Vice President of India and went on to become the second President of India in 1962 to 1967. He was born in Eastwhile Madras Presidency near the Andhra Pradesh and Tamil Nadu border. Being a bright student, he completed his education by winning scholarships. After completing his MBA, MA, he taught the subjects in Madras Presidency College. He was Vice Chancellor of Andhra University from 1931 to 1936, followed by Vice Chancellor of Banaras Hindu University in 1939, succeeding Madan Mohan Malviya ji. The story behind Teachers' Day goes that when Dr. Radhakrishnan took the office of second President of India in 1962, his student approached him to seek permission to celebrate September 5th as a special day. Dr. Radhakrishnan instead made a request to them to observe September 5th as Teachers' Day to recognize the contribution of teachers in the society. We are happy to have this event on 5th September. In last two sessions, we have dived deep into basics of deep learning and deepfake technology. For third session, we have our expert, Mr. Akshat Gupta, machine learning engineer, Nivea Life Care. We are happy and delighted to have him for the session. He has deep knowledge in the domain of natural language processing in healthcare. Mr. Akshat describes his mission as to get education and healthcare available to every single person on the earth. He is a machine learning engineer with an insatiable intellectual curiosity and ability to mine hidden gems located within a large set of data through data analysis, followed by feature engineering and then training model and putting it into the production, followed by deployment on AWS and GCP. As a machine learning engineer, he enjoyed bridging the gap between machine and intelligence, combining many technical knowledge over real-life problems to create an intelligent product. His goal is to always build products that are intelligent and efficient under the hood while providing engaging analytical and result-oriented user experience. When he's not in front of the computer screen, he's probably thinking over an idea or around the chessboard or spending time on knowledge acquisition via book or MOOCs. So now, without taking more time, I hand over the session to Mr. Akshat Gupta. Thanks a lot, Mr. Akshat Gupta, for uh, giving us a permission to have your session. So over to you now for the fruitful session further.
Sure. Thank you very much for this warm welcome. First, I would like to extend my thanks to Purnima University for providing me such opportunity so that I can speak and directly interact with the students and share my knowledge and what I'm doing in the industry with the students and with everyone, with faculty and everyone. Then after that, I would say a very good morning to all of you and a very happy Teachers Day.
Thank you.
Yeah. Okay. So, are we also taking questions in between in the YouTube live session?
We will be taking questions in the last of the session, or if you want, I can do that. I can just check the stream also and the chats over here, and then ask you the questions,
Okay.
whichever way you prefer.
Sure, sure, sure. Thank you. Okay, so let me share my screen.
Thank you.
Please. Is my screen visible?
Just a minute to know. My screen is just a minute. I think you have on that YouTube channel screen.
Okay.
Yeah, we have started having we have participants on channel also, and here also.
Hello,
Yeah,
madam. What happened?
yeah, I can see that YouTube screen नहीं सर ठीक है पता नहीं है सर की स्क्रीन वो हो गई है शायद फ्रीज हो गई है अक्षत कैन यू हियर अस
Yeah,
मिस्टर अक्षत
I can hear you.
I think your screen has freezed and we are able to see only that YouTube screen
Okay,
over
Yes,
okay.
here.
yes. That's the YouTube screen.
So if I want to join, okay, it is from here.
Now, sir. Now you can try
Yeah,
it again.
yeah. Is it visible now?
Fine, sir. Huh? Working, working.
Yeah. Okay. So
Yeah. We
yeah,
can see your presentation.
you can see the presentation.
Yeah.
Yeah. So, good morning, everyone. Myself, Akshat Gupta. I am working at Naval Life Care as a machine learning engineer. I'm software innovator at Intel. I do Kaggle sometimes in my free time. And I am also a great supporter of open source contribution. So, I used to contribute in open source projects in speech processing, natural language processing, and all. And I'm also working as a member of board of studies where we discuss and define how we can make industry technology accessible to university curriculum. Okay, so this is agenda for today's session. We will see what is machine learning, some applications of machine learning. I know there has been multiple sessions on it, but it's just basic introduction of natural language processing. Then we will go through what are the applications of NLP. Then we directly come on healthcare, what type of data we got in healthcare. Then we look into like NERs. NERs are like named entity recognition models, and we will also see how it works with the demo, a deployed model on the cloud over AWS. Then we will see one more case. Then we will see some look at. We will see about voice and speech data, how it looks like, how we can work in speech data, how we can do speech processing, what are the applications of speech processing, and like how we can how we can get different features from speech, and on top of that, how we can build the applications. uh, for an example, gender detection using machine learning, using different like convolution neural networks or Gaussian mixture models. We will see, and we will also see this all these things in the form of code, how we are implementing these, and how we are getting our results. Then we will see in something in cyber security, because security is something, I would say, which is the least explored field in terms of machine learning. So we are also doing some work in cyber security in the open source. So you all know about phishing. We will see about phishing attacks, then a specific type of homoglyph based phishing attacks, and how we have solved this problem with a good like 92% of accuracy. And like when we create machine learning models, a lot of machine learning models are there, but if we see the stats, then only let's say 5 to 8% of models are able to go into the production. They are not able to go into the production due to limitations or computation limitations or some other limitations. So we will see how we can put the machine learning model into production using Docker, using Flask, and all these things. How we can make a scalable model, and how we can put into production over AWS and all using AWS services, or we want to use a bare machine, simple. We want to deploy using a Linux instance and all. So we will see all these in the upcoming session.
Uh, Akshat, can I take 1 minute to welcome Mr. Vipin Prakash?
Yeah, sure.
Uh, we have Mr. Vipin Prakash Yadav, RTO event coordinator, also joined with us. So I welcome him in the event. Over to you,
Thank
Akshat.
you.
Welcome, sir. Over to you, Akshat, again.
Sure. So now the question is, what is machine learning? You all know, like it's very popular these days. Machine learning is a way by which we are not explicitly hard coding a problem or solving a problem. Rather than doing these things, rather than explicitly programming the solution, we are training machine based on certain examples, certain instances, and based on that, let machine take the decision. Like for an example, if I tell you in layman terms, there is a child, like 1 year child or 2 year child. So he doesn't know like how to walk, how to speak. Then the parents of the child taught him like A for apple, B for ball, C for cat, like other thing. This is how to walk, this is how to drink water, all these things. And what happens, like say if you are telling a child like, see, this is apple, this A for apple, say one time, and if you'll ask the child what is this, maybe like child will not be able to tell what is this. Then again, we do this on daily basis, like A for apple, again second day, third day, and after certain number of days, like say 1 month, when we ask the child what is this, then the child eventually says like this is apple. So the process by which the child goes through is called learning. So he learned all those things, and in system and when we try to perform learning with the help of machines, we call it machine learning. Then there are some applications of machine learning. So we are using machine learning every day, everywhere. When we are using our assistants like Google Assistant, Siri, Alexa, Cortana, we are saying something like, "Hey Google, wake me up at 5 a.m." So it is able to understand that natural language. So like if we say this to a person is able to understand because the person is intelligent. He understands that language. But a machine is also able to understand not everything, but some instances of it. So that is where machine learning is being used. if you see the App Store or Play Store, Google Play Store, where you be download Android or iOS apps. So suppose you have downloaded two games, you can say fighting games or racing games. So it will show you recommendation based on your interest. So that is recommendation systems to, and these are personalized recommendations for a person. Then the third application is face unlock, which we use in laptop and mobile phones as well. So like when we see someone, we know he's this or she is this, and but how system is able to do it? When the camera sees us, it is able to identify this is this person, I have to open the lock, or this is not this person, I do not have to open the lock. There are multiple things going into it. For an example, I can also show an image of a person who has set it the lock, but there comes liveliness detection, where we check whether there's a real person or not. So these all are applications of machine learning. Then if you see, if you everyone have used Uber, Ola, or any other like ride hailing services. So see, like when you're booking for a Uber from place A to place B, it will show you some amount. But when there is raining, it understands like it's been raining, there is shortage of cabs. So to optimize the profit, it will show you dynamic pricing based on the real environmental conditions. That is again the very good application of machine learning from the company's perspective. Then Google Maps, everyone have used Google Maps. If there is traffic on some specific road, then it will show you the another route, like you should go by this route. So it is having less traffic, and you will reach your destination in less time. How it is able to do? It is able to understand, identify these are the routes, this is the traffic, and with the help of the data, it is taking it is taking it is recommending us to travel via this route. So again, there is machine learning is going on behind the scenes. Then there is email filtering. So you have used Gmail or Yahoo Mail or any other mailbox. If you go to spam, there are a lot of mails which are in spam, which are in promotion, or which are in updates. And if we usually go and check our spam box, mm, I would say 95% of mail are there, which are not useful. So how Google know, how Gmail knows like this email is not useful, and it marked is as a spam based on the content of the mail, based on the URL of the mail, or maybe it is something else. It is a phished email, so it is not of the use. So again, machine learning is going on behind the scenes. Google search, when we do a Google search, it takes various parameters into account. For an example, location and the age of the person. We usually make a profile, the gender of the person, all these things, and shows the better result, optimized result. Then the application is language translation. We use Google Translate. Like if we talk about human translator, a human translate can translate in one language to five, or say 10, or at max like 15 languages. But if we see the language translation done by machine, right now Google can translate in 108 languages. So this is very good, I would say very good application of machine learning. Like we can translate 108 languages by machine, and in some of the languages we got pretty good accuracy. Like if we say English, French, Chinese, Spanish, we got very good accuracy. But the languages with less amount of data, or the regional languages, we get less accuracy, but things are improving day by day, and all this happening because of machine learning. Then recommendation engine, Netflix, Amazon, Zomato, like when you order something, Zomato shows you like you should order this also, or people like you have also ordered this. So that is again machine learning going on behind the scenes. Churn prediction, fraud detection. Churn prediction is a process where companies try to know whether this person leave us or stay with us, who is using our service. For an example, I am using Airtel SIM or Idea SIM card, and if I am having plan to leave the, I am having a plan to switch to Geo SIM card. So like companies use different data, how I use the system, and what is my behavior in the system, what is my feedback to the system, all these things to try to make their marketing strategy better. Or you can say, when you are trying for some, when you are thinking about like I should leave this, you are getting great offers. So how they are able to know it, like you are planning to leave with the data which we are living in the system, and based on that they are giving us good offers, so we should not leave them. Then you all know about Tesla self-driving cars. It's very popular. It's a very great application of machine learning and deep learning, human speech understanding, that is NLP. And there are a lot of many more applications of machine learning in day-to-day life. If you're using system, a laptop, mobile, any digital device, there is a lot of machine learning going on behind the scenes. Okay, so I am not going into the basics of machine learning, like how we do machine learning, what is supervised learning, what is unsupervised learning, and all these things, because these are already been done by the in the previous sessions. I am directly jumping into the natural language processing. So now the question is, what is natural language processing? So it is a branch of AI which deals with the natural language. And the problem with natural language is it is very ambiguous. For an example, if I say buffalo, what comes to your mind? Buffalo as a state in United States, or buffalo as an animal who gives us milk? Or if I say bank, then which bank? Bank where we use do financial transaction, or bank of a river? So language is very ambiguous for we humans also. If someone is saying something, it is very difficult for us to understand in what context the person is talking about. So like if it is difficult for humans with such great ability and with such great computational system we have as our brain, then for system it is very difficult. And our brain is able to process all this data because we have gone through 10,000 years of our brain has gone through 10,000 years of evolution. That's how it becomes so smart, like it is able to pick things so fast. But for a system, for a machine, it is very difficult. So in natural language processing, we deals with the language data, and we try to gain valuable insights from the language data, or we try to run actions based on that language data, or we try to do interaction based on language data. Conversational AI is a very hot topic in today's world if we talk about natural language processing. And a lot of companies, even Google, Microsoft, a lot of big companies are putting a lot of money in conversational AI. But till now, recently GPT-3 is came. Like it is very good. I would say very good. But if we compare it to the language understanding of a human, then it is not that much good. That can be used in industrial use case. But the research is going on in this field. And if you see natural language processing in last 2 years, there's a lot of research. We got BERT, we got GPT-1, 2, 3, we got transformer models, lot of things in last 2 years in natural language processing. Then we got some applications of natural language processing where we are using it. So if you say language translation, sorry, language transliteration. So natural language is being used everywhere. Like when we are saying, when you were using Google Translate, we are saying what is in term, like from English to Spanish, we're saying something, and machine is able to understand and then translate. So again, it is understanding the natural language. Chatbots are very common everywhere in a lot of websites, even on, if you see on Zomato, Swiggy, on insurance platforms, like on a lot of platforms, chatbots are there. So that is again a application of natural language processing, because they deal in from the understanding of the language. Then you heard about the Survey Monkey. You heard about the different forums where there are surveys going on. So and these surveys are asking us or Amazon Mechanical Turk is one where a lot of surveys are going on. So in these surveys, people are asked with some questions, and then machines are analyzing those surveys, because for a human, it is very difficult to analyze lakhs and lakhs of reviews or lakhs of responses. Say if we talk about Amazon, like product reviews. So on a product review, you say 50, you'll find like on the popular products, you'll find millions of reviews, and on normally you will find like 15,000 reviews, 20,000 reviews. Lot of reviews are there. And suppose if I am going to buy something from Amazon.com or Amazon.in, then it is not possible for me to go through all the reviews of the people, all the reviews of the people which are given there. So we can analyze the natural language segments, and based on that, we come up to you have seen a rating, the average rating of a product, that is 4.3, 4.4, 3.5. That is calculated based on analyzing all those reviews. So that is, again, we are understanding natural language, and based on that we are generating a score. Then everyone has used Grammarly. So when we use Grammarly, there is spelling and grammar correction. There are a lot of more things like preposition, conjunctions, and all these things also. Spelling and grammar, it looks very easy. Like spelling is easy. We can do spelling correction with the added distance mechanism, or using word-to-vec models, or using like MOE model, which is a recent paper which is from Facebook Research, FAIR. So that is a very great paper. If you want to read about spelling correction, then you can go through that paper. That is MOE, Miss Obvious spelling estimations. So, and then grammar check. So like grammar check is again an application of natural language processing, but grammar check looks easy, but it is the problem which is not being solved by any machine learning model till today. It looks simple, but it is not that much simple. And why it is not easy to solve problem? Because again, the language is ambiguous, and our grammar is not structured. It is based on, like, through the evolution of last 500 years. It is not a structured language. So that's why it is very difficult to work with unstructured data, like natural language data, like if you want to do grammar correction. And there are a lot of things which can go wrong in grammar model. For an example, if we talk about some sentence like Ram goes to market. So goes is a verb here. But if I am having back pain in my back, so like pain can be the verb here, but there are two back. The one back is with the back pain, and one back is at the end of the sentence. So to understand like which one is having relation with that and what is the specific POS text, system got confused very easily. Sorry. Then we have voice assistants like Google Assistant. We talk to Google. We got to talk to Amazon Alexa. Hey Alexa, do this for me. Hey Alexa, play some song. So Alexa is able to understand and do all those things. Again, the application of natural language, and I would say also speech processing. Email filtering, this is again, we are getting emails in the form of text. So like based on the textual data, it is able to identify whether it's a spam or not, or it is able to put a relevant tag over it, whether it is an update, whether it is a payment, whether it is important. So it automatically classifies the email. So that is again the application of natural language processing. Average reviews of products on Amazon, we have already seen this. Flipkart, market intelligence using sentiment analysis, like this is the same thing on Amazon, using what customer is saying in the review, whether the review is positive or negative, whether the understanding the emotion of the user, whether the customer is happy or sad or angry about the usage of this product. So this is again all applications of, there are a lot of more applications. I am able to list down these much, but it is everywhere. A lot of applications of natural language processing and machine learning are there. If anyone wants to ask anything in machine learning and natural language processing, they can directly write in the chat section on the YouTube live. So I will be able to like answer those questions immediately. Now, like what is the use case of machine learning in healthcare industry? So like healthcare industry, which is the most noble industry, because of only healthcare, we are able to survive, and a lot of people are able to survive. Uh, so there's a lot of research using natural language processing and machine learning in healthcare industry also. For an example, identifying diseases and diagnosis. This is a simple task, but how it is used. So there is a process of we have done one project regarding clinical trial automation. So there is a lot of clinical trials all over the world where we check for clinical trials, a process where we check a certain medicine whether it is good to release in the market or not. So there are some documents called protocol documents or forms which take a lot of time. A single form took like something around 20 to 25 days in processing. But with the help of machine learning, if we are able to identify important components of that 150-page document or 200-page document, what are the relevant diseases, what are the relevant diagnoses, what are the relevant enzymes, what are the relevant proteins, and all these important things from the document, then we can list that down and make a small document. So if it is taking 20 days in processing a 150-page document, then maybe it would take 3 days or 2 days in processing like 15-page document manually by a person. So it is again NLP. This is the application of NAR, which we will see how we can identify diseases and diagnosis using machine learning. Then there is drug discovery and manufacturing. Like in drug discovery, what we do, we got certain input of the salt, and we got like the nature of the cell, how the cell is reacting, how this cell is reacting, different type of outcomes. But there's a lot of data. For a manual processing, it is impossible to process all the results, all the interaction result, gene results. So we use machine learning to identify patterns, identify good insights from the data, which is coming from the behavior of the cells or behavior of the genes. You also heard about like genome mapping. That is again a very good uh, application of machine learning, where we are properly able to map the genomes. Medical image diagnosis. So there comes an interesting fact about medical image diagnosis. If I talk about data, so image diagnosis means simple, like we are having X-ray, we are having some other image-based data from a medical report, and can we process it with the help of machine? So there comes an insight. If you can check this paper, this is a ChestXNet by Stanford University. So, what they say, the average accuracy of all the doctors in detecting pneumonia from the analysis of X-ray. This is about the US data. The average accuracy of all the doctors in detecting X-ray, in detecting pneumonia from the X-ray is something around 77% in United States. So, every year there are something around 1 million cases of pneumonia. So 1 million simply means 10 lakh cases of pneumonia, and doctors are able to identify it with 77% of accuracy. So it means doctors are able to identify 7 lakh 70,000 cases approximately. What about those 2 lakh 30,000 cases? The people who are having pneumonia may not have pneumonia, but doctors have not diagnosed it. So the 2 lakh 30,000 is a very big number. If we can reduce this number, that's a great achievement. With the help of machine learning, with the help of X-ray analysis, using computer vision and convolution neural networks, like we ourselves also done this thing like 2 years back. So like after running, as paper says, the ChestXNet says, they have run a 121 layer ConvNet, and with that ConvNet, they are able to detect X-ray with 96% of accuracy. It means out of 1 million cases, they are able to correctly identify whether the person is having pneumonia or not by seeing the X-ray. And 96% of cases, that means next 60,000, only 40,000 are people left undiagnosed or maybe with the wrong diagnosis, we can say. But it's a great achievement. Like a single model is able to give the accuracy, which is specific to pneumonia only, but it will grow in future. It is growing right now, but it is greater than the combined accuracy of all the doctors in United States. Like this is very good application of machine learning. Then there is behavior modification. So machine learning is like natural language processing and machine learning is used a lot in mental health care or like primitive healthcare, trauma healthcare. So like what can be the application of machine learning and natural language processing in behavior modification? So the people which are gone through certain trauma, certain accident, or the people who are gone through like some mental problems, we can use machine learning in a form of bots. So there are specific therapies we call like DBT, dialectical behavior therapy, or the CBT, cognitive behavior therapy. A lot of therapies are there, and how these therapies are work. There are certain sort of questions, certain sort of procedures by which we will try to motivate the person. It's therapy. So with the help of machine learning, what we try to do, we try to do these things with the help of assistants, with the help of chatbots or AR/VR assistants, and give therapy to the people. So like why it is very good, suppose if it is given by a person can give this. And if we talk about this mental health care or like healthcare, if we see the number of people who are doing this is very less. Number of doctors is very less. If you see number of doctors per 1,000 people or per 10,000 people, it is very less, and it is everywhere in United States, in Canada, in India. So we and every country wants to have a better healthcare, to have more number of doctors on less number of people, but it is not the case. So if we use machine learning for this, so it will maybe it will not give that much like 100% accuracy, but where we are needing like 10 people to do certain tasks, we reduce that to 2 people. So and rest 8 people can do different things, can give healthcare facilities to more number of people. So it is optimize. Machine learning is helping us in optimizing uh, the healthcare workforce, or optimizing the output of the healthcare workforce. Then there comes smart health records, that is EMRs, where a person speaks, where a doctor speaks and the patient listens, or sometimes patient speak, doctor listens. So we can create a smart health record based on the conversation between the doctor and patient, and based on that we try to analyze like what could be the problem, what could be the what could be the diagnosis for this, and what could be the medication. And based on that we can take decision, we can take further decision. So doctors do not have to invest time in each and everything. Then there is radiotherapy, like outbreak prediction. Lot of applications of machine learning, natural language processing in healthcare industry. So now this is about the data in healthcare. If we see like there are a lot of data sets on internet and a lot of competitions. So those data sets are structured data sets in the tabular format. But if we see the data structure in the real world, especially in healthcare industry, it is completely unstructured. So what we call the data in the healthcare industry, we got clinical notes, we got prescriptions of the doctors, doctor conversations in the form of speech, as well as converted into text form from using speech to text engines, medical reports, EMRs, and there may be other forms also. But data is unstructured. There's no tabular format. Some things, if you see prescription, let's say for take example of prescription. So something is written in prescription, like for some person the name is on the top, then age and gender, then date, then the diagnosis, then something. For some prescriptions this is something else, or some prescription the order is something else, or the content is also different. So this is completely unstructured data, and this is the biggest problem while working with natural language. Like data is unstructured. With structured data, it is very easy to train machine learning models and get good results. But with unstructured data, the main task is to get the data into the usable format, and then use machine learning or deep learning to to get the results out of it. Okay, then we are directly jumping into NER, named entity recognition systems. So NAR is basically a system which helps us in identifying named entities. For example, you can see here, Albert Einstein was born in Germany on March Day. 6 weeks later, this is a sentence, and the task in NAR is: are we able to identify some important entities? So yes, we can do this with NAR, named entity recognition systems. Like Albert Einstein, machine has recognized like this is a person. ULM, machine has recognized this is location. Germany, location. Munich, location. Gymnasium is an organization, though it is not that much correct, but from a machine level, it is good. I will say it is good. From it has recognized school as an organization, Zurich as a location. So how NER systems are able to do it using conditional convolution neural networks or CRFs with some other processes? We will not go into the details because that will require a lot more time, and we have to cover a lot of things. So we will see this, and we will see some demos of this. So NAR is basically when we try to extract the entities as a person, organization, location, monetary value, anything which can be termed as an entity. We can also make custom entity. Like for example, I am taking name of a book as an entity, and I got a list, or I got certain text, and I need to identify like what books, what are the out of total text out from the total text, how much books are there in the text. So I can make a NAR for the book recognition, and from a name of book, it will identify like it is a book, it is a book, it is a book, or it is not a book. So we can create our custom NARs also. Now, this is medical NER, like in the medical named entity recognition. So you can see an example. A patient was prescribed with magnesium hydroxide, this for 400 mg slash 5 ml, suspension, PO of total 30 ml, bid for next 5 days. But machine is able to very accurately identify all the entities. If you see magnesium hydroxide, it is a drug. This is the strength 400 mg slash 5 ml. It is a strength of the drug. This is suspension. Suspension is something which is slightly thicker than liquid. So it is a form. It can be tablet also, or it can be capsule also. It can be syrup also. It can be other thing. It can be gel also. But it is suspension is a form, and it is able to detect like this is a suspension kind of product. This is PO. PO is a root. It can be oral also, or it can be some other thing also. But the system is able to identify by which route the patient is taking. It can be injection also. Is taking a medicine. Of total 30 ml. 30 ml is a total dosage. So again, the system is able to identify like what is the dosage, and bid this, and then we have like for next 5 days. So next 5 days is a duration, like for how many days person has to take, and a system is able to identify all those things. Now we will see one demo of this. You can tell me any sentence in the you can tell me any sentence in the chat section, and I will try to run this through our demo application. Okay, this is
Sorry, yeah. Sorry, I was muted. Akshat,
Mhm.
there is
Yeah.
one query on chatbot on that YouTube that
Mhm.
customer NER needs how much data to train. And I hope somebody has written the statement. No, nobody has given the statement right now
Okay, custom NAR needs how much data to train.
to train. Yeah.
So, so this is a subjective question, I would say. How much data is needed by custom NAR? It depends on the use case also. suppose we are making a custom NAR for e-commerce industry, and on the other hand, we're making a custom NAR for healthcare industry. If you're making it for a e-commerce industry, and our model is not that much good, say it is having 70% of accuracy or 80% of accuracy, then we can bear with it, we can use it, because it is not directly impacting someone's life, in terms of like whether the person is going through something, because that is e-commerce. Person has ordered something, and it is able to detect some, this is rupees in the mail. Suppose someone has written a mail to the customer care, and we are trying to detect the entities, whether is there a mention of amount, is there a mention of quantity. This NER, we are working on, and the NAR will have accuracy of 70%. So we can bear with it, we can use it. If we are having less data also, it is not a problem. But suppose we are working in a healthcare, and we are diagnosing a disease, we are detecting a disease from a prescription. So there we cannot afford false negative, because that will do a lot of bad to the people. We need very high precision in healthcare. So if we are we are using healthcare, if we are using making a healthcare in healthcare and making a NAR in healthcare industry, so I would say we need lot of data, and this is subjective. For example, for drug and disease, we are making a model. So I would say if we will have something around 10 to 15 lakh instances of the drug and disease, and then we train a model, and model is having say accuracy of 90%, 92%. It is not bad, it is very good, but we cannot use it in healthcare. Why? Because that 8%, that 8% will be a false negative, and how it will badly affect the use case, the business. For an example, there is some person, let's talk about prescription analysis only. There is some person, and he has a mention of some protein in the prescription. A lot of proteins and a lot of drugs which are similar in name, they are interchangeably used. So there's a mention of protein, and this is a very complex problem, where we need to clearly identify between, is this is this the name we are detecting as a drug, it is not a protein, or in the context in which it is used, is it not a name of protein. But if we are like we're getting 92% of accuracy, and we are detecting the name of a protein as a name of drug, or it is not a name of disease, but we are identifying it a disease, identifying it as a disease, and it is on someone like this is a disease, then the person is diagnosed with such disease. You can say, for an example, pneumonia. We can take example of pneumonia, but actually the person is not having pneumonia. So like and the doctors started giving the medications for pneumonia to the person, whether the person is not having pneumonia at all. So I would say the amount of data we need for NAR or custom NAR model, it depends on the use case, in which use case we want to use machine learning or NAR model. And it is with every problem of machine learning, what amount of data we need, it directly correlates what impact it would have once it is being deployed or used in the industry. So I hope I have given the answer of this question.
I think we are very clear on what on the query. And yeah, there is one sentence which has been given by some participant. I have taken paracetamol 2 days, 2 times a day.
Okay,
I
let
have
me,
taken paracetamol 2 times a day.
yeah, let me run the machine from here. Give me a second. I'm running it.
Yeah, another statement is also there for demo. Mr. X is undergoing the treatment for hypothyroidism for last 5 years.
Okay, so actually I'm connecting to AWS because these systems are heavy. They require a lot of computation to
Yeah.
run, so it's deployed on
So
AWS.
whichever is possible, maybe one query you can take.
Yeah. So Okay. Yeah, we got everything. Still not- um, I think everyone can see it now. Everyone can see it. Hello, Dr. Neelam, is it visible to everyone?
Yeah, it is visible. I think clinical NLP, that is what written, and you have clicked on show drugs, strength, frequency,
Ye-
and form.
Yeah, correct.
Yeah,
So
it
can
is
you tell
visible.
me the first sentence? It is running, it is loading. It will
Yeah,
take
it
some
is
time.
loading.
Yeah. Yeah. So can you tell me the sentence? It is take paracetamol.
Yeah, okay, that sentence you want me to tell. Okay,
Yeah.
I'm sorry. I thought I have to watch that window and I have taken paracetamol 2 times a day.
I have taken
Taken paracetamol two times a
paracetamol
day.
2
Times
times
a day.
times a day. Okay. So there is one thing I would say, the paracetamol is missing with strength, so I would add it 650 mg. This is the actual doses of Calpol. So let me say analyze. This is running. So it is, I have taken paracetamol, that is drug, 650 mg of strength, 2 times a day is a frequency. So this is, and we are getting like the label with the where it is starting and ending in the form of word index, in the form of character index also. Like this is at this position, at this position. So we can try some other also with dosage, with more things into it.
So Mr. X is undergoing the treatment for hypothyroidism for last 5 years.
So that is for the disease.
Yeah,
Okay.
I don't think the sentence is complete in the terms of.
So that is for the disease.
I think this is taking, the machine is taking time.
Minute, then this is there. So we want to check for disease. So the disease is, can you tell me the sentence?
Yeah, just a minute. Mr. X is undergoing the treatment for hy- hyperthyroids for last 5 years.
in terms of hyper, Hyro, yes, Mr. John, say the last one, yes. Hyperthyroidism, I don't know the spelling is correct or not. Let's see. Yeah, so it is able to detect like hyperthyroidism is a disease. It is given the uh,
This will be
indexes
useful.
also.
Okay.
So we can try some other disease or some other drug strength, frequency, form. We can put in multiple things if you want to try, or if anyone wants to try something, I can try it on this entity recognition model for drug and disease detection. Okay, let's check one more here. Take paracetamol 650 mg and Zephyr 200 mg twice a day for 10 days. So there also it has detected paracetamol. It's a drug. 650 is the strength of this drug. Then the second is GFE is the drug. 200 mg strength of this drug. Twice a day is the frequency, and for 10 days is the duration.
Yeah.
So this is all we are seeing in presentation. This all is running in real time, like disease and drug identification from the documents. Okay, let me continue from here. Yeah. So this is about the one simple small application of NLP, how we are using NLP to identify different things from the medical records or patient records, and we are using it for further processing. Like we are having a lot of medical records, say 1 lakh. For a doctor to identify and go through all the medical records and identify from the medical record, this is the disease, this is this, a system can do this with very good accuracy, like in NERs, in detecting entities in terms of medication and in terms of disease identification. We got like very good 90, 91, 92% of accuracy, though accuracy is always subjected to the data available to you. Suppose, and why I'm saying this, suppose you have say 20 examples, 20 data points. You have trained on 15 data points, you have tested on 5 data points, you get all solved, you get 100% of accuracy. Now one more example, you have 20,000 data points and you want to test on 5,000 data points. On 20,000 data points you have trained the model, on 5,000 data points you have tested the model. Out of 5,000 you are able to correctly detect say 4,000, so that's 80% of accuracy. So, accuracy is always subjective to data. You have seen a lot of papers, research papers are saying we got the accuracy of 95%, we got the accuracy of 99%, and they claim themselves to be state of the art, which we call SOTA, state of the art, like we got highest accuracy. But this is a suggestion, always look into their data sets, what type of data they are using, what amount of data they are using, because accuracy is subjective. If I am taking 100 data points, I can easily get 95% of accuracy. But if I have 1 lakh data points or 10 lakh data points, it is very difficult for me in problem like these to get that much, like 97, 98% of very high accuracy. Yeah. Then we will discuss about some applications of speech and voice. What is speech? What is voice? You all know what is speech, the way by which we express our thoughts, communicate to each other. That is speech in general terms. But from the analytics perspective or from a technical perspective, speech is nothing but an energy signal in the environment with respect to time and space. If we say something, I'm saying something, if someone is saying something, what happens basically, we are saying something, there is energy disturbance in the environment, and that energy disturbance goes in all the directions, and the person who wants to listen it, they listen it, like they understand this energy disturbance in the environment, and the same thing we call the same thing as speech. It is having multiple features like amplitude, duration, pitch, timbre. A lot of features are there for speech, but we will see like how we can do speech processing. It's an energy signal. So how we can process the energy signal? It's a sinusoidal wave, I would say. So how we will process it, how we will detect different things using speech processing, we will see. So there's a specific feature called specific features called MFCC features. This is basically male frequency substitute coefficients. What are these? In layman terms, there is some process of taking inverse Fourier transform, then going through cosine transform to get the MFCC. But basically, what it is, we basically feed an energy signal to we say for now consider the how we calculate MFCC feature, consider it as a black box. So how we calculate MFCC features, we input an energy signal, and based on some computation, it gives us some values, say like a value of array of different numbers, and it can range from 500 to 1500 depending on the voice signal. And what are these numbers? These number is the, I would say, numerical representation of an energy signal, which we can, like if we want to process data in the system, we want to get the things in number, we have to get the things in numbers, because system can only understand numbers. System cannot understand anything other than numbers. If we will say language also, we convert language into vectors using word vector or count vector or tf-idf vector, any other vectorization method. Again, at the end, these are numbers which system is understanding, and based on the pattern in those numbers, system are making conclusion. In speech processing also, at the end, we have to get the numbers. So we are using MFCC sampling of an energy signal to get the energy signal in the form of numbers. I would say a array of certain values, which will have some meaning. We will see what is MFCC feature, how it look like, what is the distribution of MFCC feature. So this is how to get MFCC feature. We will see how to get MFCC feature from this link. This is like we are working on this open source project called VoiceNet. Okay, if you will see here, we are using Python speech features, and it is directly implemented there. We are getting delta from SciPy. We are using wave function from scikit-learn preprocessing, importing some basic machine Python libraries, I would say. So what it does, we get a file as an input in this function, and it will read the file from this path, and we will pass the signal here, the rate and the lower frequency for the signal, that at which lower frequency we want to compute the MFCC feature. And then we'll get some output. We will pre-process this MFCC feature. Then we will stack these MFCC, we will horizontally stack these MFCC feature into an array, and then we can use it. This is for a single file, but we will do it for a lot of files, and then we will a lot of energy signals or a lot of audio files, and then based on then on those audio files we can do a computation. Okay, then we will look at the gender detection model using machine learning. So there are two methods. One is Gaussian mixture model, one is CNNs. With Gaussian mixture model, we get the accuracy of 95. With CNNs, it's fabulous. And I would not say this is absolute accuracy, because it is based on the data which we have. We've used ST American data set, and whatever data it has, like something around 4,500 samples, based on that, we have spread it into train and test, and we got this accuracy. Maybe if we try this model with say 10 lakh data points, we get our accuracy to 80-85% or even 75%. So all this is subjective to amount of data we are having at the desk right now. So we will see this.
हाँ हाँ बिल्कुल बिल्कुल
Yes. So this
एक टाइम पे
is
हाँ
basically gender
सर
detection
एक मिनट होल्ड कीजिए तो अच्छा
based
आप
on
बताइए बोलिए
voice.
बोलिए बोलिए
Yeah, this is gender
जी सर
detection based on the voice. We are getting a energy signal, basically the voice signal, and the task is at hand is we need to
जी सर
identify the gender from the voice signal. And in this sample
वो
study,
अपने उससे करा
we
रहे
will
हैं
be
पर्सनल
using Gaussian mixture models to identify
हाँ
gender
सर
from the voice signal, which is based on using MFCC feature.
प्रॉब्लम तो नहीं आ रही सर
There
उनका
are
भी
other
परचेज
features also PLCC feature, LOF feature, PLC feature. A lot of other features are also there, but in this, for now, we are using MFCC features. So we'll see. Like we have imported some of the basic libraries, SciPy, Pandas, NumPy, Python features, scikit-learn, and all. Then we will import the data. So this is FreeST American dataset. If you want to do it by yourself, you can go to this link and try this. You can get the dataset from here.
क्या होंगे
You will see this is the dataset. This is 351 MB datasets. FreeST American English corpus. It is audio files in which people, males and females, are speaking in English language.
नहीं मेरे सब गेम को ओके
Okay, we have done till here. So this is simple data manager class where we are reading the data. We got the zip file. We are extracting the file. Then we are making different folders for males and females. Then we are naming the files from 001, 002 to for all the files. Then we are moving the files here from a common directory to male to female, and this is the procedure to use all these functions. We're making training data, testing data. Parent training data we have female, in training data we have male. Again we have female and male for testing data. This is we are doing there in this manage function. Then we have run this with this zip file. We got the file expected, training data was created, testing was created. Then these folders are created for training and testing as well. And we have our data structure. Basically, the way which we want to process the data, we have that ready. What is MFCC? We already know what is MFCC. We first take the Fourier transform of the time domain signal, and where we separate the source part and the filter part with the help of multiplication. Then we will map the powers of the spectrum on the Mel scales, like whatever we are getting after doing the Fourier transform, we map all those things onto the Mel scale. Then we'll compute the MFCC for this. So this is the same feature expector for the data. There the code is same which we have seen for getting the MFCC out of energy signal or voice signal, voice file or speech file. So there we are passing audio path, and from that audio path, it will return the MFCC feature for that. This is the function, and these are specific parameters which we are passing to function. Now, what is GMMs? GMMs are basically a Gaussian mixture model, which is a probability density function based on the numerical values. It will, and based on the data in the numerical values, it will try to find the probability, or which is again based on the expectation maximization algorithm. Like, what is the maximum likelihood of this specific data point where it would be belong to this class or this class. It is not a deep learning model. It is simple machine learning statistical model. Okay, so there, this is model trainer. So we got like we got initial paths, we got the features, then there we are processing, and yeah. So here, if you will see,
We got male female voice features. We got male female data. We have trained models on male and female, and we fit the model like GM model. Here we create an object of GMM which is there in scikit-learn, and then we fit the model, and whatever model we are getting, we are saving the model as male and female in male and female directory as a male GMM and female GM. Then the training is going on for these sample. These are the sample data points we got in the data set. And these are the file names basically. 87.wave. It's a wave file. Wave file is for sound. So this training is going on. Yeah. And if we see here the training is completed, then this is testing code. We are testing for test data. So there we are loading testing data for female and male and both the models which we have trained for male and female. So the testing is going on, and we already have the label like whether the input is female and male, and this is expectation like female, it is already a female, and it is identified as female or not. So this is the file, and expectation is female. We got the female. Expectation is female. This is like with the F. So all these are for female samples, female testing samples. We input the F like female samples, and we are getting identified as a female sample in lot of these. In I would say in 95% of cases. And if we will see what is the accuracy, we can see here like the overall accuracy of this model is 95.749%. So we in this sort of simple small case study, we have seen how we can use Gaussian mixture models to identify the gender of a person from a voice signal. So this is one case study. Then we will see how we can do this with convolution neural networks, and there we will get much better accuracy. We will increase the accuracy from 95 to almost 99%, 99 or I would say 99.5% using convolution neural networks. So yeah, it is here. Okay, so there we are doing the same thing. We are getting the raw data, and we are using Keras to train our simple. First, we will train a simple neural network model. Then we will train a convolution neural network model. So there we are importing models. We are importing layers to make our neural network. Dropout for regularization, batch normalization, and simple like plotting for plotting. We are using uh, pyplot, matplotlib pyplot from matplotlib. So this is data. You can see these are the different files. The same file, female for female, it is with F. For male, then we have moved the file into appropriate directories. Then we are getting MFCC feature. We are creating MFCC features, and we are flattening them so that we can feed them into neural network. So what we have done, we have first taken sample voice inputs, then we have computed MFCC features out of it, and then in a vertical stack we have stacked all the features, one all the array values. We have vertically stacked all the array values in the form of feature for every file, and we have saved it with corresponding to the file name. Like if this is the file name f001, this is the feature, this is the file name, this is the feature. We have called this function on our train data. If we see, we have like shape of the train. We have 2557 data samples here in the training data set, and 1521 is the number of columns, basically the number of features we have, which is coming from MFCC only. Then here we are making vanilla neural network, very simple. First, we are defining our sequential model. Then we are adding one layer, which is having 256 unit. We are using ReLU activation function. and there we give input dimensions, which is equivalent to shape of the training data. Then we are adding one batch normalization layer. Like if anyone is having any question about any of these, they can just ask anything. What is batch norm? What is dropout? What are these layers? Why we use it? Why we have not used some other thing? So anyone can ask anything. We have used Relu here. Why we have used sigmoid in the last layer? Why we have used one neuron here? They are 32. Where we use 128. So there are specific reasons to each and everything, like why we are in certain facility and why we are using these specific numbers only. We can use like some other number. We can use like 264 also here, 254 also here, or we can use 512 also here. But why we are using this? So there is specific reasons for that. Then we have designed our neural network architecture here, and then we have compiled the model with the optimizer, with the Adam optimizer. What optimizer does in neural network, it simply accelerates the training process. We are getting our metric as accuracy, and we are using loss for like binary cross entropy. Since we are doing binary classification, we got two classes, male and female. If we got multiple classes, we have used categorical cross entropy, but we got two classes, that's why we have used this. Then we have fitted our model and train our model on trained data. For 200 epochs, batch size is 64. It means in a single computation, it will take 64 samples into account. And the validation spread we have set to 0.2. It means 20% of data will be used for validation out of total data. From the trained data, we will use 20% as a validation data, which will validate. And you can see there we are getting accuracy and validation accuracy. So this we have trained our model using this, and we can see we got like very good accuracy using vanilla neural network. That is something around 0. If you see here, this 0.9961. In 36 epoch we got 0.9961, and next like 32nd epoch we got 0.9980, and there we got something around 1, that is complete 100%. So it's very good, and neural networks are very good when we have good amount of data. Like if we have good amount of data, I would say go for deep learning, go for neural networks, and it will give you very good, great accuracy. So we have run this for 200 epochs, and if you see the graph of training accuracy and testing accuracy, so you'll see on the 0 epoch it started from, in the 0 like first epoch itself, it has raised the accuracy to something around 99%. Then it has fluctuated there only till 200 epochs, and finally we got this final accuracy 0.961 with vanilla neural network. Then yeah.
Akshat, would you like to take one or two questions which are pending on the question answer board?
Yeah, sure.
Yeah, there is one question. Why it is called a vanilla neural networks?
Okay.
And another question was related to the software which you have shown, that if you checkbox disease, if we click on that, will it show disease or not? I mean, in which disease we can take paracetamol in your system, which you have shown. I don't think it is going to show whether the disease is which diseases you take this particular drug.
Yeah, so let's take second question first.
Yeah.
For which disease we want to take paracetamol? This is a decision-based question. Like their system has to take decision, and there comes a new field which are decision-based systems or decision systems or decision-based machine learning. So like if we want to do that, like if you want to know from a machine in which disease we can take paracetamol, so we can, this model is not for that. This model is NER model, but obviously we can train a model to get to know like in which disease we can take paracetamol, or we are putting in the symptoms and the machine is giving us the recommendations for the diseases. Like I am having headache, I am having fever, I have this. We are putting in the symptoms, and then machine can recommend the diseases. to us. We can it's again like I would say multi-label classification problem where we are getting certain set of features and we are computing the disease, which disease we have to take based on that. Now let's come to first question: why it is known as vanilla neural network? Sure. So it is called as vanilla neural network because it is very simple. Like first, it is a simple. I would say it's a sequential neural network. It is very easy to implement. It is very simple. It is having sequential layer. Then we are having dense layer. Then like it's sequential. Some like if you try to visualize it, then you will see like first we are having inputs which are having like 256 neurons. After in the second layer we are having one more layer where we're having 128 neurons. After that we are having batch norm and it is very basic, very simple. That's why we call it vanilla neural network. And sometimes we call this type of deep learning also like or machine learning also like vanilla machine learning, because vanilla is like very simple. It's not like a butterscotch, but it's the starting point. Vanilla, simple one. I hope I have answered the queries of the students. Uh, so I have like 30 minutes left. Am I right? Hello, Dr. Neelam, are you there?
Okay, I muted myself, so you were not able to hear me. Actually, I have 5 minutes left. It is 10:15, 9:45 to 10:15.
Okay, it's only 5 minutes left. So I think I should say some more, one to more case studies on deployment of machine learning models. So skipping this and let's see some of the things in the action directly. So this one more case study in cybersecurity, like
Uh, One more
like
thing, it will take only 5 minutes now so that I can inform the next speaker.
yeah,
Okay,
yeah,
thank you.
yeah. So this was the case study on phishing. As less time is left, so I would directly jump into some of the things. Uh, Before that, this is one more study on phishing. Phishing, you all know what phishing is. It's a way by which the people, basically the hackers, try to do a fraud. It's a cyber crime using the false identity of the bank site, or I would say as the email account or like that. You can check different phishing accounts at openfish.com. If there is time, I have shown you, like they look exactly similar. If you see the phishing page of PayPal, it will look exactly similar to PayPal. Then there are specific attacks called homoglyph attacks. So I'm skipping it for now, and let's jump to the last topic, which is in how to deploy machine learning models, and let's see it in action. Yeah, so this is about the Docker. What is Docker? Docker is a service platform, I would say. Like what happens in industry, in machine learning, we train some model for machine learning on our system. It worked well, everything was fine. We have used TensorFlow, we have used PyTorch, and all of the libraries, bunch of libraries. But when we try to deploy the model onto the production or onto cloud, it usually the code breaks up there. Why it breaks up there? Because the environment we are having on our system and the environment of the server are different. So and this is very common problem, or like there are some updates on the server and the code breaks, the service goes down. This is very common problem in deployment. So for that the solution is Docker. We are using Docker to by which what we do, like we create a copy of our environment, or we will create an environment on the top of the hardware, and instead of only putting code onto the server, we try to transfer, or we try to put complete environment, our complete environment onto the server. And then which we call it container, like we put our code into the container, we bind it and put it on the server, we open the container. So code is running on our environment only, like the environment which is in on our system. There's a small demo how we can use Docker. So let me show you that. Okay, so there it is. CD. We are here, and if we see this is very simple. A Flask application which says, "Hi, welcome from Akshat Gupta. Use masks in coronavirus." If we run this application on our system, we'll see. So we have environment here, which is Docker Flask environment. So first we activate that. Then we'll try to Python 3 app.py. So we can see application is running. If I open it, so this is simple basic Flask application which is running on my system's environment. This is, "Hi, welcome from Akshat Gupta. Use masks in coronavirus." This is running on my system, and if I will try to put this code onto the server directly, there are a lot of chances that it will break. It will not work like that. Now what we will do, we will try to create a Docker environment for it. So for Docker environment, we have to create a Docker file first. Docker file is created from the extension of Docker file, and there we write our commands, like how we want to run it. Like first we will get the Python. This is we are basically from command we are fetching the version of Python from Docker Hub. Then where we want to copy our code, what is our working directory. Then we will install the requirements onto the server. Then we, as our code is running on port, so we'll expose the port, what command we want to run, and what is the like entry point of our code. So we are basically running Python 3 app.py. So there we have written everything like in the sequence in the Docker file. Now to create a Docker file, we do like this is the build command for Docker. So if we use this command, let's say we try to create a new Docker image for this. So this is creating a Docker image for my environment, creating a Docker container for my environment. So it will take some time because it is creating the image of the environment and everything which is there onto the system. Once it is done, like it is performing all the steps one by one. First, it has fetched the Python from Alpine, Python 3.7. Then it is copying the steps we have defined in the Docker file. So it would take some time. Then what we do once it is built, then we try to run the Docker application. We can instantiate Docker with the Docker command after installing the Docker, and then we pass the name of the app and on whatever port on local machine from the Docker machine we want to map, we map and we run the Docker file, Docker app. Like our name is Docker app, we run the Docker app, and yes, yes, talking about. I think the time is over. So I hope we can continue these things in future. We can again reconnect. The other speaker for the conference is waiting, so I should conclude now. But there are several things like how we can create a Flask ML API demo, and how we can put our model into production using AWS EC2, how we can use a data app using a Streamlit, and some AWS deployment. But like due to time limitation, I will stop there, and I will hand over to Dr. Neelam. I would say thank you very much for attending the session. Thank you to everyone, and especially to Purnima University for providing me this providing this honor to interact with the students.
So, Mr. Akshat, your session was going on very well. We never wanted to stop it, but unfortunately, we also have time constraints. So we have to continue with other speaker. But definitely, we would like to have you again for some day else for continuing the session and to understand other aspects of the technologies which you are supposed to take today. I'm quite sure that this session, means I'm very sure that this session might have given a very good insight to all the participants about how this particular applications can be deployed in an actual practical world when these applications go, how they work and what are the concepts which have to be taken care and all those things. So thanks a lot for such a wonderful session.
Thank you.
And we really had a wonderful session, and thanks a lot.
My pleasure. My pleasure. You're welcome.
Thank,
Yeah, thank you.
so,
Thank you, everyone.
so welcome to the fourth session. We have Dr. Sugata Sinha, Assistant Professor, VNIT Technology, Nagpur with us. So we will be starting off with our second session.
Yeah. Hello, madam.
Yes, sir.
Am I audible?
Yes, sir, you are audible.
Okay, thank you. Thank you
So
very much.
should I start the session, sir?
Yeah, madam. Yeah, I'm ready.
Yeah.
I'm ready. Okay. So, madam, I just want to share one PPT.
Yes, sir. You will be able to share through
Okay.
your screen. There is an option,
Okay,
share
okay,
screen.
okay.
You will be able
Okay,
to do that.
I'll do the share screen now.
Yes. So we are privileged to have him for the session. He will be imparting knowledge in the area of machine learning and medical imaging. Dr. Sugata Sinha received his PhD degree in imaging science from Chester F. Carlson Center for Imaging Science, Rochester Institute of Technology, USA, in December 2014. He joined the Department of Electronics and Communication, Visvesvaraya National Institute of Technology, Nagpur, as an assistant professor in 2015. Before completing his PhD, he worked as a research scientist in Samir IIT Mumbai project, which is funded by Government of India Research and Development Institute for 3 years. His research interests include medical image processing for cancer detection and ultrasound imaging pattern recognition. I request you, sir, to take over the charge of the session for the experts talk.
Yeah. Madam, thank you very much for this nice introduction. Okay. So first of all, I'd like to thank the organizers for arranging this type of symposium or this type of FDP, because the topic is very, very relevant. And specifically, I like to congratulate the organizers for successfully arranging it in these trying times, because this is not like a normal FDP. Actually, I would very much like to visit there, because I haven't visited the place. So I haven't visited the place. So I very much like to visit there, but because of these times, it is not possible. So So that's
Maybe-
why, that is the special reason that I wanted to congratulate the organizers, because they thought of organizing this instead of all these restrictions, all these problems. So so I need the organizers need a special mention and special accolades for organizing.
Sir, I
Very
would like to interrupt you that, yeah, definitely we would also like to have you on our campus
yeah.
whenever the conditions permit us.
Yes, definitely. But since they have put a lot of effort to organizing this, or for organizing this, I'd like to I would like to congratulate them. And secondly, I'd like to congratulate them because the topic is very, very relevant here. So whatever we are doing in deep learning and machine learning, we need to know a few things. Actually, I always think that we need to go back to the basics of what we are doing. So, and many people, and nowadays the scenario is that many people are using machine learning and deep learning, but the problem is that most of the people, they are not aware of the basic things in machine learning. Okay, so how I see the problem is like that. So it is always a nice thing to sometimes, if some people just remind us that, okay, you always need to refresh your basic ideas, why you are doing and what you are doing and how you are doing, then it will be a real boost for whatever you are working. And since I was going through the speakers, I saw that there is a nice mix of academicians as well as industry people. Okay, so we academicians, we may get quite boring sometimes because we'll talk about the basics, we'll talk about the theory, but it will be the industry people who will actually show you how these things are being used by industry. So there are actual hands-on applications of these things, which are actually being done by different people in industry. So that's again another very positive point of this FDP, that there is a nice mix of speakers, not all the speakers from academia and not all the speakers from industry. So that is a very nice mix. Okay.
Thank you, sir.
So, okay. So again, thank you very much. Thank you, Dr. Chaplet, and thanks to Mr. Yadav for inviting me. Okay. And let me start my talk. So as everyone, before starting my talk, I was forgetting. So today is a very special day. It's the 5th of September 2020, and as I am a teacher, and I think that many of our participants or the listeners, they are also maybe teachers, I don't know, but even if they're not teacher, I think even the students, they are the best teachers. So I'd like to wish all of us a very happy Teachers Day. Okay,
Thank you. Thank you, sir. And
Happy Teachers Day, sir.
We also wish from Purnima College of Engineering a very happy Teachers Day. And to inform you, yeah, most of our participants, you can say around 90% participants are teachers only.
Okay. Yeah. I was thinking like that. That's why I specially mentioned about them. Okay. Thank you. Okay. So without further non-technical things, I just like to start our technical topic. Okay. So as the title of the talk, as you can, okay. So just let me clarify. My full screen is visible to everyone.
Sir, your screen is visible.
Okay. Thank you. Okay. So whenever I present or whenever I teach, I like all the sessions to be very much interactive. So if anyone wants to ask any questions, I think the preferred mode of asking any question is writing down something in chat. Okay. So please feel free to do that anytime. You can write any questions in the chat window. I don't mind. If you want, I don't mind. Because I like always my sessions to be a two-way communication. It will not be just whenever I teach. Also, I always encourage students to ask questions, even if they need to stop me at the middle of my talk. I don't mind. I always encourage questions because otherwise I don't feel comfortable. Okay. So, so I don't know what is the preferred way of asking questions here, but I think, as far as you can write questions in the chat window, that will be okay. Yes, madam.
Yeah, sir. We have a chat window also and question answer board also. So I will be
Okay.
keeping a eye on those areas. Along
Okay.
with it, this is being live on YouTube. So there also, if any question is there, I will put it in front of you.
Okay, okay, okay. Thank you very much. Thank you very much. Okay, okay. So this will be the content. So first of all, I'll talk about general framework. Okay, general framework of machine learning in medical imaging, and then I'll talk about learning methods. Okay, so this is not exclusively to medical imaging. These learning methods, they are actually basically general machine learning environment. So what are the learning methods available for general machine learning? And then we'll go to supervised learning. So there are two types of learning methods: supervised learning and unsupervised learning. So first we'll talk about supervised learning, and then we'll go to some theoretical basics of some examples of supervised learning. So it is very popular. Everybody is familiar. Probably everyone has heard about the name artificial neural network, or ANN. So we'll talk about a little bit more about artificial neural network. Again, I'll go to the basics of ANN, and then we'll touch SVM. We're not going to go into detail of SVM, but we will touch SVM. We'll just see what is SVM. So these will be the two examples of two mentionable examples that we'll be covering here on supervised learning. I'll also touch convolutional neural networks, so CNN, which is very popular nowadays. And then we'll go to unsupervised learning. Okay, so what is unsupervised learning? And we'll take one example of unsupervised learning, that is autoencoder, which is also now very popular nowadays. And then I'll show you some results. Okay, I'll show you some results that our lab or my group has done. I personally did, and some of my students and some of my collaborators did on for photoacoustic for prostate cancer detection using photoacoustic imaging. So we applied some of these techniques, some of this algorithm for prostate cancer detection using photoacoustic images, and I'll show you some results about that. Okay, so this will be the content of my talk. So general framework. So this is this block diagram. These different blocks show the general framework of application of machine learning. Okay, so generally machine learning is used for classification. If I want to be very specific, then it is generally used for classification. The most popular task the most popular task that is achieved using machine learning is classification. Okay. You can say someone can say segmentation can also be done. Yes, segmentation can also be done. Someone can say regression can also be done. Yes, regression is also be done. But if you really think hard, then all these regressions, segmentations, all these things, actually classification is a subset of regression, and segmentation, actually using machine learning, segmentation is achieved again via classification or via regression. So my point of view is that classification is the major task. So I'll talk more majorly about classification. So in the general framework, the first block is data acquisition. Whenever we are talking about medical imaging, in fact, any kind of imaging, the first step is data acquisition. So I want to acquire the data. For example, many of you are familiar with, so since we are talking here about medical imaging, so many of you, I think almost all of you, have at least once or twice visited any kind of radiological laboratories. So probably you are familiar with ultrasound imaging, or X-ray, normal X-ray imaging, or X-ray CT imaging, or magnetic resonance imaging. Probably either you have visited for your own or for your near or dear ones, or you have at least heard about those things, that these things are there. Okay, so these are actually different imaging modalities in which you are acquiring, your lab technician or the doctor, they are acquiring data. So whenever an ultrasound imaging is being done, so ultrasound image data are being acquired via some specific type of sensors. Okay, so that is the first block. So the first block is whenever you will visit to any radiological lab, the first block will be they are going to collect images, or they are going to collect data on your specific on your specific organ or something like that. Okay, so first step is data acquisition. So data will be collected by technicians or radiologists. Okay, next step is image reconstruction. So after data acquisition, the images will not be automatically formed. Okay, so whatever data we are going to acquire, that data will be in raw form. Okay, so just looking at the data will not be able to interpret anything. So that data will not show you any anatomical or functional information about your organ, about your specific organ, or about the organ of interest itself. So from that data, we need to create an image which will show that which will provide some kind of information to the radiologist. Okay, so the first step is data acquisition, and the second step is image reconstruction. There are various algorithms for doing different type of image reconstruction. Actually, this image reconstruction itself is a specific domain in medical imaging, and many researchers are working on producing crisp, good quality images from raw acquired data. Okay, the second step is image reconstruction. Okay, the third step is ROI selection. ROI is region of interest. Okay, and then the fourth step is feature extraction. I'll in the next slide I'm going to again describe all these steps in a bit more detail. Okay, so I'll just mention here the steps, and in the next slide we are going to talk about all those steps in more detail. Okay, so after feature extraction, we are going to do classification. So here the main part of machine learning is coming, that classification, task of classification. So we'll be talking about this classification task throughout the next portion of our talk. So how to do this classification? For as I mentioned, that there will be different learning methods. So the supervised learning, unsupervised learning, all of them will be used for achieving classification. Okay? And then next, the final one is decision making. So once the classification is done, okay, so you have done the classification, then you are going to decide. So you are going to decide which part of the image, or which part of the image, or which part of your organ is problematic, or which part is not problematic, or as a whole, whether there is some problem, whether there is some problem with organ, or there isn't any problem with organ. Whether there is something to worry, or whether there is not something to worry. If there is something to worry, how much we should worry about that, and based on those kind of decisions, the doctor will decide what will be the next course of treatment. So the doctor will decide how to manage your problem, and then he'll start the therapy. Okay, so these are the different steps or different blocks of the general framework. Data acquisition, as we are saying that so many of you are familiar or may have already visited. Okay, different radiological labs where data acquisition are being done. Okay, so data acquisition, different imaging modalities are there, and for each imaging modality, different hardwares and imaging protocols are there. So for ultrasound imaging, if I want to perform ultrasound imaging, so I need to use transducers. Okay, I need to use some specific kind of sensors which are known as transducers, which convert pressure waves into electrical signals. Okay, and then there are specific imaging protocol also. If I want to perform X-rays, then I need to use X-ray source and X-ray radiator. If I want to use MRI, magnetic resonance imaging, then I need to use a big magnet and radio frequency coils, and then again the suitable type of sensors. Okay. So for each imaging modality, there will be different hardwares. There will be different so inside the hardware means source as well as sensor, as well as the back-end electronics attached to the sensor. Okay, and different imaging protocols. Okay, so how we are going to do image? So first of all, how am I going to place my source on which part of the body, from how much distance of the body should I place my source? Where should I place my detector? So what kind of what kind of reconstruction algorithm, no, so how we are going to do, how we are going to acquire the data. So that is actually imaging protocol, and these imaging protocols are different for different modalities. Next step, image reconstruction, as I mentioned again in the previous case. After data acquisition, you're going to get raw data, and this raw data, they are not going to provide any information to you or any information to the radiologist. So for presenting some information to the radiologist, you have to produce 2D grayscale images. You have to reconstruct grayscale images from the raw data. You have to create grayscale images from the raw data. That is known as reconstruction of grayscale images. So there are some, as I mentioned earlier, there are some different reconstruction algorithms. So these are some of the very popular reconstruction algorithms are back projection, comprehensive inverse algorithms, just to mention some of these. Okay. Next one is ROI selection. ROI full form is region of interest. So once the images are reconstructed, okay, I need to identify the ROI. So suppose somebody has gone to a clinic for breast imaging. Okay, so the breast images have been acquired and the breast images are reconstructed. Now, once the breast images are reconstructed, the radiologist will look in the image, and he will try to find out that which areas are interesting to him. Okay, so if the majority of the images will contain the normal areas. Okay, so uninteresting areas mean that nothing to worry about. But in some cases, there will be some kind of abnormality. Okay, and depending upon the presence of the abnormality, the radiologist will determine this region or that region is containing some kind of abnormality. So I will focus my attention more towards those regions. So those regions will be my region of interest. So region of interest, they are going to actually contain some more informations. Okay, so that the radiologist will focus their attention towards those region of interest. Okay. So generally, ROIs are selected corresponding to different pathologies, or pathologies means different abnormalities present in the tissue. Okay. Feature extraction. Once the regions are selected, once the regions are identified by the radiologist, then we come into picture. We means the engineers. Until this, data acquisition has been done by some technician under the supervision of radiologists. Image reconstruction, yes, image reconstruction also has image reconstruction algorithms and all these things. Also, they are implemented by engineers. This ROI selection, the ROI selection will be done by radiologist or the histopathologist, something like that. But they'll be done by the medical people, the doctors. Now, feature extraction. We are going to suggest to the radiologist that these are the type of features that can be very much interested corresponding to a certain pathology. Okay, so every pathology and every imaging has certain kind of markers, which are also known as features. So for example, if I just want to give you some example, so for X-ray images or ultrasound images, suppose that a lesion has been identified. Okay, suppose that suppose a radiologist has identified one lesion, and if the boundary of the lesion is quite smooth, then the radiologist will probably say there is nothing to be worried about. The boundary is quite smooth, and depending upon the other presentation, depending upon some other presentations also. But this is one type of presentation I'm just mentioning. If the boundary of the lesion is quite smooth, then radiologist will probably not to worry too much. But if the boundary is not that smooth, if it is jagged, if it is rough, then the radiologist will focus his or her attention more towards examining the lesion in more detail. So what I mean to say is that the smoothness of the boundary is one type of marker which may provide you the information that the lesion may be cancerous or the lesion may be malignant. So these are certain type of presentations or markers of certain tissue pathologies in images, in medical images. Okay, so once the radiologists have identified the ROI, our job will be to extract as much possible, extract these markers as much as possible. And for extracting these markers, we need to design some algorithms which will extract these markers, and these algorithms are known as feature extraction algorithms. So the markers will be extracted in the form of features, what we know in the form of features. Okay. So the next step is feature extraction. Now the final step, and now the next step will be classification. Okay, so we have acquired the data, we have reconstructed the image, radiologist identified the region of interest, and on the region, from the region of interest, we have identified some useful markers corresponding to a particular pathology. Okay, we have identified, we have extracted the useful markers. Now, once the markers have been extracted, okay, now we are going to apply some machine learning algorithms, and those algorithms will tell us at the end of these algorithms, we are going to find out whether the region of interest identified by the radiologist, whether they are actually corresponding to some kind of tissue pathology, or whether they are normal. Okay, so the aim of the classification will tell me that what is the probability, what is the chance that a particular ROI belonging to a particular tissue pathology or belonging to a particular tissue disease. So the classification algorithm will give me some kind of value or some kind of chance or some kind of probability of a particular region belonging to a particular disease. Okay. Now the last step is decision. Now, so the classification will tell me some kind of probability for a particular ROI belonging to a particular disease. Now, based on the probability, the doctor will decide, along with the engineer probably, doctor will decide whether that particular region needs to be further investigated or further treated. So the decision will be taken by the doctor. Okay, the decision majorly it will be taken by the radiologist. Okay, we cannot take the decision. We can only show the classification output to the, but at the end, doctor will take the decision. Okay. So again, I just wanted to mention that. So these are the different steps of the general framework. But what I really wanted to mention, if anyone is thinking about doing some machine learning work in medical imaging, then it is very, very important that you need to do a collaboration with a doctor. Okay, you need to do a collaboration with a doctor, because see, the end users are radiologists or they are doctors. Okay, so depending upon the requirement of the doctor, you need to design your algorithm. You need to perform the classification tasks. You cannot just perform the classification tasks on your own and go to your results to a doctor and tell the doctor, just accept these results are very good, and I think these results will be suitable to your aim. No, this is not done. The doctor will tell you the requirement, and you need to satisfy the requirement of the doctor. Okay, so if you are thinking of doing some machine learning in medical imaging, it is very, very, very essential to do a collaboration with an actual radiologist or with an actual doctor. Okay, otherwise I don't think it will be very much fruitful. Your research may show some very good results, but whether these results will be applicable in practice, those things are doubtful. Now, classification. So as I mentioned, that majorly we'll be talking about majorly the machine learning is confined in classification. So we'll be talking about classification in detail. Okay, so I'll go to I'll start using some kind of symbols. Okay, so for classifications, so the feature vectors. So now I'll introduce the term vectors. Probably you are all familiar with vectors, but I'll still just to mention those things, that capital X represents vectors. Vector is a combination or is a collection of different scalars. So all these small values, small x1, x1, x2, x2, they are scalars. Okay, and the combination of all these scalars, they are the capital X. This is a vector. This is a feature vector. So we are going to collect, we are going to calculate, we are going to extract different different examples of this capital X from a region of interest. Now, once the features are extracted, then we need to find out whether the features belong to different classes. Okay, so for example of different classes, so if I'm trying to detect prostate cancer, so there will be two classes, cancer and normal. There may be three classes, cancer, benign and normal. Okay, so we need to, so our task is to determine whether a particular feature vector belongs to a particular class. Now, for doing that task, we are going to form functions. We are going to form, here I have written formation of M functions. We are going to form some functions, F1, F2, Fm. Now, we'll decide the fourth step, feature vector X belong to Ci if Fi of X is less than Fj of X. Okay, so we'll decide that if we'll decide or we'll conclude that my feature vector X belongs to a certain class Ci if we say, if we find out that function value of the function, value of a particular function Fi corresponding to that feature vector is less than the value of the function Fj obtained using the feature vector. Okay, so feature vector X will belong to Ci if Fix is less than Fjx. And so formation of these functions and all this, they are actually depend upon different learning methods. So when I'm going to change the different learning methods, the formation of functions will change. Okay? So this is the, again, this is the general framework of performance of classification. The important things are, first you need to I need to construct my feature face. I need to construct my feature space using the extracted feature vectors. Then I need to determine that how many classes are there in my problem, how many classes are there. As for example, I mentioned, if I want to detect prostate cancer, if I want to detect cancer, then there may be two classes, cancer or normal. There may be three classes, cancer, benign and normal, something like that. And then this formation of functions is actually your actually formation of your classifier. And then the conclusion whether a particular feature vector belongs to a particular class will be done by this fourth step. Okay, and then there are different learning methods, that means different classifiers to consider. So this is the general framework of classification. Now, learning methods. As I mentioned, there are two different learning methods, supervised as well as unsupervised. So supervised, what is to supervised mean? Supervised is involves some kind of training. Okay, so the first point I mentioned here, that supervised learning methods, they use labeled data or labeled feature vector to learn the classes. Okay, so what does this labeled data mean? Okay, so labeled data mean is that in supervised classification, what is done, I'll tell you what is done. So for supervised learning methods or supervised classification, the engineer will start the classification process with labeled data. Labeled data means what? Labeled data means the data corresponding to labeled data for the data points. For each of the data points, I know the class to which it belongs. That is the labeled data. Labeled data means, let me say that again, labeled data means each data point, the corresponding class to each data point I know. So for example, if I again tell the same example of prostate cancer, then I know for each data point, I know whether it belongs to cancer or whether it belongs to normal. I know the labeling of each data point. I'll start with this labeled data. Now, then the next step is formation of training, validation, and testing. Okay, so supervised learning, it involves training. Okay, so using the data points for which I know the labels and I know the corresponding classes, I'll train my classifier. So I need to form training set and I need to form testing set, and sometimes validation set is also required. Okay. So, and whenever you are forming this training and testing, you need to remember, so whatever label data you have, you need to divide that label data into training and testing. You need to remember two important things. First thing is that the assignment of each label data, training and testing, they should be done completely randomly. There should not be any bias. You cannot just say that, okay, so I'll form my training set using the first half of the label data, and the second half of the label data should constitute the testing. No, it should not be done it like that. Constitution of training and testing set should be done completely randomly. First point. And the second point is there should not be any overlap between training and testing. Okay. So the same data points cannot be used for formation of training and testing. So training and testing, they should be, and if you want to form validation, so training, validation, and testing, these three data sets should be completely independent. Okay. Third step, selection of model. So actually, which classifier you want to use? Do you want to use ANN, artificial neural network? If you want to use SVM, if you want to use linear regression, if you want to use random forest, whatever, if you want to use CNN. Okay, so depending upon which classifier you want to use, you need to select the model. So the third step is selection of model and corresponding cost function. Okay, so for each model, there comes a cost function or error function. I'll go back to that in more detail in my future slides. So I'm not going to talk about cost function now, but the third step is you have to select your classifier and the corresponding cost function. Okay, so in the fourth step involves training. So now you have formed your training, testing, validation set. You have selected your classifier and the corresponding cost function. So now what you want to do, you want to train your classifier using your label data for achieving that particular task. So again, if I want to go back to, if I want to use the same example of prostate cancer detection, then I have some data for which each data point is labeled either cancer or normal. Okay, I have those known data with me. Now using this known data, I'll try to train my classifier. Okay, I'll try to train my classifier in such a way that at the end of the training, my classifier knows how to recognize a unlabeled, unknown data, whether the unknown data belongs to cancer or whether it belongs to normal. So this is the aim of training. So training will be done using the label data set, and the aim of the training is that after my training is done, my classifier should be trained to identify which data points belong to class 1 and which data points belong to class 2. Okay, so this is the aim of doing training. The fifth step is model parameter updated towards minimizing cost functions. Now this is actually done in the fourth step. This is actually done in training, but I wanted to mention that. So whatever model we are going to select, depending upon the model, there will be some model parameter. So if I select ANN, then there will be weights and biases involved. So weights and biases, I need to tune those weights and bias values in such a way that my classifier at the end of the training will be able to recognize that whether for an unknown data point, whether it belongs to class C1 or C2. So that thing is being mentioned here. So those model parameters I need to update, or I need to train, or I need to tune for minimizing cost function. And by minimizing cost function, I'll be achieving the task of identifying any unknown data point, whether it belongs to class C1 or C2. Okay, now the training is done. Once the training is done, so once my classifier is trained to recognize any new data points, now what we are going to do, I need to actually check the performance. I need to check the performance, how well my classifier is trained. And for checking the performance, I am going to use the testing dataset. For checking the performance of my trained classifier, I'm going to use the testing dataset. So for testing dataset, I know the labels, but I'll not tell my classifier that these data points have these labels. For the classifier, the testing dataset is without label. Okay, so the classifier will do what? It has already been trained. It will accept the data points without labels, and it will assign the labels on its own. Okay, it will assign the labels on its own, and then I'm going to check, since I know already that what each data point, which data point has which label. So I'm going to check whether my classifier has done the job correctly or not. Okay, so that's how it is, its performance is going to be measured. Again, I'm going into two basics, but I think I should do it. Okay, the next learning method, the next type of learning method is unsupervised. Okay. So in unsupervised learning methods, there is no label data. Okay, so labeling is not there. Labeling is not there. Okay, so so I need to learn the classes without any label data, without any labeling. The data points will be there, but the corresponding labels will not be present. So I need to learn the classes without, so there will be no training here. Okay, so the training using the known labels will be absent here. So I need to learn the classes without the labels. And the second step, that again here also we need to select the classifier. And in the second step, I need to initialization of the classifiers. Okay, so I need to start with at some point. Okay, so I need to either for k-means, I need to select the number of classes and number of class means or class centers. Okay, so for k-means, if my number of classes is 2, then for k-means the value of k will be 2. Okay, so something like that, initialization of the class parameters. Then again, we have already selected the cost function and the model, and in the third step, we are going to find out the value of the cost function corresponding to the input feature vectors or input data points. And the last step is that updatation of the classification parameters. Okay, updatation of classification parameter towards minimization of the cost function. So this is the framework, general framework of unsupervised methods. The major difference you need to remember, the major difference between supervised and unsupervised is that no label data point is present in case of unsupervised method. Okay, so in medical imaging, we prefer unsupervised learning more than supervised learning. Although I can say that majority are doing supervised learning. Okay, majority are doing supervised learning. But unsupervised learning is the ideal one. We want to achieve unsupervised learning, but since we do not want to take any risks, so that's why we are doing supervised. But we want to actually, ideally, we want to do unsupervised learning, because in many cases, specifically in medical imaging, the sufficient data points with labels, they are not available to us. Okay, and they are quite difficult to obtain. Sufficient data points with accurate label, they are quite difficult to obtain. Okay, so and even if I obtain that, the labeling itself is a quite, what should I say, complicated task, and this should be done by quite skillful radiologists or skillful technicians. The labeling of the data points. Okay, so even if some kind of errors are there in terms of labeling, then my classification accuracy will be affected. So in that way, the accuracy of supervised classifications may be compromised if there are some errors at the time of labeling. But in unsupervised, it doesn't use any kind of labeling, so those type of errors will not be there. But there are some other problems of unsupervised also. That's why mostly supervised learning is being used nowadays. But the ideally, if we can perform unsupervised, that will be the best scenario, idea. Now supervised learning algorithms. So they are very basic supervised. So most of the examples that I have given here, that Bayes classification, linear regression, artificial neural network, support vector machine, they are very basic and very popular. So that convolution neural network, the last example, that convolution neural network, that is a little bit advanced network, or people are using convolution. Actually nowadays convolution neural network is not also advanced, that almost all the people are using convolution neural network. Okay, now, so someone can ask the question that why I am still bothered about this Bayes classification, linear regression, these, or ANN or SVM, all these kind of things. Because nowadays, if you see the publications, that you'll find out that probably almost no one is using those kind of classification, because these are very basic classifications. Okay, but I still want to explain that, I still want to learn that, because these classifiers will explain me the mechanism of classification, the aim of classification, the idea of classification. Nowadays, I'll digress a little bit more, but I'll try to tell you the problem of doing research in machine learning in case of medical imaging. Okay, so nowadays people actually think that doing pattern recognition, doing machine learning in medical imaging is quite easy. Okay, because the codes are already available in the internet. So what you need to do, you need to acquire the data, you need to get the data. Okay, and you need to download the code from the internet, and you need to use you need to tune a little bit your code depending upon your data, and you need to use the code with the data. But it is not like that. It is not like that. There are plenty of codes, plenty of algorithms available in the internet, but each of the algorithm has their own limitations and advantages. Okay, that's why you need to know and you need to understand each of the algorithm before deciding to use which particular algorithm for which type of data. Okay, there are certain drawbacks. So people are almost, I don't want to mention any number, but majority of the people do, at least in India, they are using convolution neural network whenever they are doing some kind of machine learning task. Okay, but there are some kind of drawbacks of using convolution neural network also. Okay, so the number of network parameters are huge. You need a huge computation facility to do convolution neural network. And in case of practical examples where you do not have the authority, or do not have the luxury to implement those kind of computational complexity or computational resource, CNN may not be a good solution. Okay, CNN may not be a good solution. But still we are using CNN. In fact, I am also using CNN. So I should not say any negative words towards using CNN, because CNN is a beautiful algorithm. But what I need to stress is that before using any algorithm, we need to understand the algorithm. We need to understand its limitations and its advantage. We should not use blindly the algorithms. So the Bayes classification. As I know, this is very basic, so I'm not going to devote too much time towards that. Okay, so I'll just mention. So probably all of you are familiar with Bayes theorem. So the first step is the posterior probability calculation using Bayes theorem. So here, just let me mention these things, that capital X represents feature vectors or the data points, and CKs are different classes. So if I say that my aim is to do cancer detection, then CK will be C1 and C2. So K will be equal to 1 and K will be equal to 2. Probably C1 will say cancer and C2 will say normal. Okay, so there will be two classes. So PCK given X. Okay, so PCK given X, that is known as the posterior probability calculation, that will be given by PX given CK likelihood multiplied by PCK prior divided by PX. So this is the base formula. So once I calculate the posterior probability, then I need to calculate the cost or loss function Lij. Okay, so this loss function will tell me whether X actually belongs to so this loss function, the value of the loss function will be decided by this factor. If X actually belongs to Ci, so so here Lij represents the loss function corresponding to this factor if X actually belongs to Ci but classified as Cj. So Lij represents the loss function corresponding to the scenario when X actually belongs to Ci but classified as Cj. Okay, so this is the symbol, this is the meaning of the symbol of the loss function Lij. I need to calculate mean loss. Okay, I need to calculate mean loss corresponding to classifying X to Cj. So Rj is the mean loss. Rj is calculating how? Rj is being calculated how? Rj is the summation of Lkj P Ckj, k equal to 1 to capital M. Okay, so if for our example, the cancer detection, M is capital M is 2. Okay, so I need to find out Rj for two different classes using this formula. Now, one thing that I want to ask in the fourth step, one thing that I want to ask, Lij, we are going to assign some values of Lij to Lij and Lji. Okay, so Lij is what? Lij is the loss corresponding to when my X actually belongs to Ci but classified as Cj, and Lji is what? When my X actually belongs to class Cj but is classified as class Ci. Okay, so should I assign the same values to Lij and Lji? That is a thing to be thought about. Okay, so for emphasizing on this, I just gave an example here. So now let us say that X is X actually signifies magnetic resonance image of a cancer patient. Okay, now C1 is the class corresponding to advanced cancer. Okay, here our task is to determine advanced cancer. We are dealing with advanced cancer here. So C1 belongs to advanced cancer. Immediately therapy is required. C2, no cancer, no therapy is required, normal. Okay, now just think on that whether L12 and L21 should be same. L12 is what? L12 is the cost or loss if X actually belongs to advanced cancer but classified as normal. Okay, and L21 is what? L21 is where if X actually belongs to normal but classified as advanced cancer. Both these scenarios are undesirable. Both these scenarios are undesirable. I should not, for an actual for a normal patient, I should not classify, I should not conclude for a normal patient, I should not classify him as a cancer patient. Okay, that is undesirable. But in case of an advanced cancer patient for which immediate treatment is required, I should not classify him as the normal patient. Okay, so that is much more dangerous than the first scenario, than L21. So that's why we should always assign much more loss or much more cost to L12 than L21. L12 and L21, that they should not be treated as same loss. Okay, so the next step, if Rj is less than Ri, then our classifier will conclude that X is classified to Cj, class Cj, and the final step, finally I just mentioned that Lij, how I'm going to assign values to Lij and Lj, Lij will be equal to 0 if j equal to I. Okay, and Lij will be equal to 1 for j not equal to I, without any prior knowledge. If I do not know that what kind of classes we are dealing with, what kind of danger of the classes we are dealing with, what kind of importance our classes have, then I will assign this. But if you know that we are dealing with advanced cancer, then depending upon the severity of the problem, you can assign much more values to Lij. Okay. Linear regression. The next is linear regression. The next type of classifier is linear regression. Okay, so again, the first step is selection of your model. So model Y is equal to W1 transpose X plus B, which can be also written as W transpose XAP. Here, your XAP is the input feature vector. Okay, and W is your model parameters. So here I have just written, so in the next line I have just written W vector. Okay, and I have written XAP vector also. And in the next step, we need to decide that what should be our loss function or objective function. So here we have taken a mean square. If we have taken a sum square error lost as the loss function. So L is equal to half multiplied by summation of W transpose X minus TI square. So W transpose X is actually the model output, and TI is the actual output. Okay, so there are two different things here. So TI is the class level, actual class level, and Y will give me the output of the model. So here, what we are, L is determining what? L is determining the difference between actual output and the model output. Okay, L is determining the difference between model output and actual output. And our aim is what? Our aim is to reduce L. Our aim is here to tune my W in such a way that value of L is minimized. Okay, that is at the end of the training, I should achieve that. I should get W values in such a way that L is minimized. Okay, that is the training. So for linear regression algorithm, the training will be, after training, I'm supposed to get those values of W for which L is minimum. Okay, so here again it is L is written in a different, using a different syntax. Okay, and if I solve this model, for solving this model, it is a maximum minima problem. So you can easily solve it by differentiating L and making it equal to 0, and then finding out the corresponding value of W. If you progress in that approach, if you progress using that approach, then you will find out you can theoretically derive W is equal to phi transpose phi inverse phi transpose T. Okay, this can be done analytically. This can be done analytically. The problem with this is that this involves computing inverse matrix. This involves computing inverse of a matrix, which may not be desirable in some certain cases. So there is a get around of that also. So you can use some kind of optimization algorithm. There are various optimization algorithms using which you can also reach the minimum L. We are going to talk about those in the next slides. Okay, so this is basically linear regression. Now we'll start talking about neural network or artificial neural network. Okay, so this is the most basic neural network. A single layer neural network is known as perceptron. Okay. So basically, what are these? So these are input nodes. There are input nodes are there, and then some links are there between input node and this. There is a sum node here. There is a sum node. So there are some links. Links are between input nodes and the sum nodes, and corresponding to each link, there is certain weight. Okay. So the input of the sum node will be weighted sum of the inputs. That means x1 multiplied by w1 plus at the weighted sum here, at the weighted at the input of this node, we are going to give or at the output of this, the sum node will be, sorry, output of this sum node will be x1 w1 plus x2 w2 plus dot dot dot, dot something like that. And then there is a activation node. So this activation node will use the output of the sum node. That means it will be fed with x1 w1 plus x2 w2, and it will produce some kind of output depending on the activation function. So actual output will be function of summation of wi xi. I is equal to n to n, 1 to n. So this is a single perceptron. Okay. Now we are going to, now this is a feed-forward network. So feed-forward network, it is a type of multi-layer perceptron. So in case of perceptron, single layer, we have seen there is a single layer, but here for feed-forward ANN, there will be multiple layers. Okay. There will be multiple layers. So basically, there are 3 types of layers. Here I am not saying 3 layers, I am saying 3 types of layers. So input layer, hidden layer, and output layer. So input and output, there will be 1 input layer and 1 output layer. Now there can be multiple hidden layers. If you want, you can include multiple hidden layers. Okay. Now see, this is a fully, this example is a fully connected feed forward network. Fully connected. Why? Each node in one layer is connected to each node in the next layer. Okay, that's why it is fully connected layer. And why it is feed forward? While calculating the output at the output nodes will be always progressing forward. So from here, from x1 I'll come to z1, from z1 I'll come to y1. For calculating the output of y1, I'll be always progressing forward. That's why it is known as feed forward. Okay. Now again, you see here that each link has been given certain weight. Okay. So here for I like this type of nomenclature. So for each node, each weight, what I am going to do, so WMN will signify that weight value of the link which is received by, so WMN is, okay, so WMN is, yeah, WMN is the weight between XN and ZM. Okay, so WMN signifies that weight value corresponding to the link which is received by ZM and which is started at XN. Okay, and that superscript 1 signifies that WMN actually belongs to layer 1. Here WKM is the link weight corresponding to the link between YK and ZM. So WKM is the link, is the weight corresponding to the link which ends at kth node and which started at mth node. Okay, here this superscript, here this should be 2. It is incorrectly mentioned as 1. So it should mention that this weight is corresponding to the link which started at second layer. Okay, so this is now forward propagation. Now, so once the network is finalized, okay, once we have decided that how many hidden layers will be there and corresponding to each layer, how many nodes should be there. Okay, once this network is finalized, what you need to do, initially we need to choose some values of weight, we need to assign some values of weight, and we need to find out output of each node other than the input, other than the nodes in the input layer, because in the input layer we'll be producing the input data points as inputs, and we need to find out output of each node present in the hidden layer as well as present in the output layer. Okay, so output of each node will be calculated using this formula. So weighted sum of input, weighted sum of the input, so xi multiplied by wji, summation of xi multiplied by wji, I is from 1 to n plus bias. There will be a bias term. Okay. Now this is this AJ is the input to a particular node. So what will be output? Output will be equal to the output of a particular activation function. So each of these node will be given an activation function. So the node will accept AJ as input, and it will produce output as ZJ. ZJ is what? ZJ is of H of AJ. H is the activation function. Okay. So these activation functions, they are non-linear. Okay. They are introducing non-linearity. Otherwise, you see all the relations, they are pretty much simple. They are just addition of products. But these H, they are introducing non-linearity. So they are the activation functions. Okay, so using the same formulation, we can determine. So using this equation, using these input values, we can determine the inputs of Z1, and using the activation functions, we can find out the outputs of Z1. Then for Y1, we can use the output of Z1 as input, and using the weights here and the inputs, we can find out, and as well as the activation function, we can find out the output of each node in the output layer also. Okay, so like that we can progress. So this will be the final for this particular network that I showed here. This will be the final output value. Okay, this will be the final output value. And here this is one typical example of an activation function. So here, see, as I mentioned, this is a logistic sigmoid function. As I mentioned, this is activation functions are nonlinear or a little bit complex. So this is one particular example. The logistic function is 1/1 plus exponential minus a. You'll see a particular characteristics of that. You'll see that when a turns to plus infinity, then this thing becomes 1. When a is 0, this thing becomes 0.5. When a is minus infinity, this thing becomes 0. So output, if I apply logistic sigmoid function as the activation function, whatever may be the value of the input, the output of the node will always vary between 1 and 0. Okay. So the activation function is doing what? It is accepting the inputs, whatever input it may be, and then it is compressing the output between 1 and 0. What is next? Okay, so we have decided for a neural network, we have decided that what should be the number of hidden layers. We have also decided what should be the number of nodes in each hidden layer. That means we have finalized our architecture. And the next step, we have also initialized weights. So as I mentioned, that we need to assign some random values at the start of the training procedure. We need to assign some random values to each weight. We have done that. And using those random values of weight and using the actual inputs, we have calculated the output of each node, and we have calculated the output of each node at the output layer also. Then what? Okay. So this is the first iteration, you can say. Okay, the first iteration in the first iteration, we have initialized the weight values and we have calculated the output of the all output nodes. Then what should I do? Then we should be calculating error. Okay, we should be calculating error. Again, this ANN is one example of supervised algorithm. Okay, so we know the actual labels. Okay, we know the actual labels. So we need to find out the difference between actual labels and the output of ANN. Okay, this is the error. Okay, so we need to find out that error. So there are different types of error functions. So one is MSE, mean square error. One is cross entropy. The equation is given here. Okay, so we can use any of these error functions, but we need to calculate the error. Next step is very, very important. Now we have calculated. So first we have determined our architecture, then we have initialized the weights, then we have calculated the output of each node at the output layer, then we have calculated the error between output of each node in the output and the actual levels. We have calculated the error. Now we need to do what we have seen. We have seen that our error is very high. Okay, our error is very high. If our error is very low, if our error is 0, then I do not need to do any kind of thing, any further thing. My classifier is already trained. But I'll not find that. I'll find that after this initial step, my error is quite high. So what do I need to do? I need to change certain things. I need to change certain things to reduce my error. Now, what to change? Okay, what to change here? I do not have any authority on input data because those data points will be there. I cannot manipulate those data points. So what can I change? I can change the model parameters. So I can change these W values, okay, these weight values and bias values. So I'll change these weight values and bias values in such a way that my error will be minimized. Now, when I say in such a way, I'll need to hurry because I have only 15 minutes left. So when I say in such a way, I need to change my weight values in such a way, they are those in that way is known as optimization algorithms. Okay, so this gradient descent optimization is one example of this optimization algorithm. Okay, so in this gradient descent algorithm, this is the formula. This is the formula that we are going to use. In gradient descent, we are going to use gradient of error calculated with respect to weight values. Okay, and the weights will be updated using this formulation. I want to explain it more, but as I do not have much time, so I need to hurry. So that's why I cannot explain. Okay, so in this equation, eta is the learning rate. So I need to perform multiple iterations. I need to update my weights multiple times towards achieving that minimum error goal, my minimum error goal. Okay, so this is one type of gradient descent. This is also known as stochastic. This is known as stochastic gradient descent or online gradient descent. So there are two types of two different ways where I can find out where I can perform this upgradation. So in the data set there will be multiple data points. Okay, so what can I, so for weight updation, what can I do? I can either choose to update my weight after passing each data point through my architecture. Okay, so first data point, I'll pass my first data point. I'll apply my first data point to the input node into the input layer, and I'll calculate the corresponding output of the input data point. Then I'll calculate the error, and then I can choose to update my weights using this formula. Or what I can do, I can first calculate the errors corresponding to all the data points, and then I can choose to update my weights. So these are two different procedures. If I want to choose the first one, this is known as online updating. Okay, and if I want to choose the second one, this is known as batch method of learning. Okay, the stochastic gradient descent is a kind of online updating. Okay, so again, there are error back propagation. Probably you have heard of this time. I wanted to discuss this in more detail, but I have to skip it because I want to show the results. I want to show you some results. That's why I do not have time. So I'll just mention this error back propagation. So when I'm training my neural network, so first step is calculating the outputs corresponding to each input data point. Then the next step is weight update. Okay, now for weight update, you see wait, if I want to use stochastic gradient descent or any if I want to use gradient descent, so see, you'll see that here in the second part of the right hand side, calculation of gradients of error with respect to different weight value, we need to find out. We need to find out the gradient of error with respect to all the different weights. Okay. So for calculating these gradients of all with respect to all different weights, I need to do this error backpropagation. Error backpropagation is what? I know my errors only at the outputs. Okay, so only at the outputs I know my error. So probably I'll be able to find out gradient of error with respect to weights corresponding to the links between output and previous hidden layer. But how am I going to find out the gradient of error with respect to these weights, the weights between input and hidden layer? For doing that, what I need to do, I need to back propagate my error through this. Okay, we need to back propagate my error through this, and that is how, using chain rule, we are going to find out the error. We are going to find out the gradient of error with respect to all possible weight values. Okay, that is the error backpropagation. So unfortunately, I do not have to go through each step. Okay, these are the steps. So I do not have the time, so that's why I'm going to skip those. Okay, so this is the error backpropagation algorithm, and all these artificial, whatever I'm talking about, artificial neural network, these things are I have taken those things from the book mentioned by from the book titled Pattern Recognition and Machine Learning by Christopher M. Bishop. So all these things are in that book. If you are interested, you can always go to the book and consult that book. Now regularization in neural network. Okay, again, I do not have the time to discuss in detail. I have only 10 minutes left. I do not have the time to discuss in detail. So I'll just mention what is regularization and why it is required. So whenever we are doing training, there is a problem of training that if I want to train my algorithm exhaustively or in detail, so there is a problem of overfitting. Overfitting, what does it mean? What it means that there is a possibility that my classifier will be trained too much for my training set. Okay, it will be trained so accurately corresponding to training set that when I'll be doing testing, my results will my performance of the classifier will become quite bad. Or in other words, my classifier will be tuned to the specific data set known as training set. It will not be trained to the general data set. It will not be trained in a general data set. That problem is known as overfitting. Okay, I want to avoid that, and for avoiding that, one method for avoiding that is to use regularization. In fact, there are different methods of regularization also. I have mentioned here 4 different methods, but again, I cannot go through all those 4 methods. But generally, this weight decay, okay, this is the probably you'll be finding out this is the most common method used for regularization. Okay, so for regularization, what we are going to do, we'll be adding additional terms with our cost function. So normally, if you are using MSE, so with MSE, you'll be adding additional penalty terms. So you don't want your weight values to be very much exact or very much specific towards accommodating your training data set, or towards minimization of error corresponding to your training data set. Okay, that's why you are introducing here the penalty term. So this penalty term, so now my modified cost function, I want to So instead of using this as a cost function, I'm going to use this as a cost function. And while training, I'll try to minimize this cost function, modified cost function. Okay, not the previous cost function. Okay. Okay. So now that there is now support vector machine, which is very popular and very effective, but nowadays it is not being used widely. So in support vector machine, again, in a nutshell, I'll just mention support vector machine. What is being done? We try to find out margins. Okay. So suppose that my data here, just look at this example. Suppose my data is separable. Suppose my data is linearly separable. For this example, it is linearly separable in some kind of feature space. It is separable, okay, into two classes. And then I need to find out a hyperplane for which y equal to 0. Y is the model output for which the hyperplane, model output will be equal to 0. Now my margins will be what? My margins will be two surfaces which will contain some data points, okay, which will contain the nearest data points to the hyperplane. Okay, that will be my two margins. That will be my two margins. So one margin is this, and one margin is the surface containing the green data points, and another margin is the surface containing the saffron data points. Okay, and in support vector machine, these margins are maximized. Okay, these margins are maximized, and the corresponding weight values and biased values are found out. Okay, and using these corresponding weights values and biased values, the data points on the margins are computed, which are also known as support vectors. So at the end of the training, we'll be finding out support vectors. Okay, and once we find out support vectors, in terms of the support vectors, then every unknown data, I'll just determine the position of every unknown every data point with unknown labels. I'll determine the position of every data point with unknown labels, and according to that, I'll do the classification. Okay, so if I'll just check. So if a new data point sits here, so I can say that it belongs to class C1, and if it sits here, then I can say it belongs to class C2, something like that. Okay. Now convolution neural network. Okay, as I said that most of the people are using convolution neural network or some variations of convolution neural network nowadays. Okay, so the convolution neural network, so one part of the convolution neural network is exactly same as artificial neural network. That fully connected part, it is exactly same as convolution neural network. So the additions are that convolution, the filters or convolution layers. These convolution and pooling layers. These are the additional things. Okay, so if I add these units, convolution and pooling, with fully connected artificial neural network, then I am going to get convolution neural network. Okay, so what is the role of convolution layer? So if you apply some input data to a convolution layer, so some filters will be there, and output of the convolution layer will be the output of the convolution between the filter and the input data. And then pooling, what it will do? It will just reduce the dimension of the convolution output, depending using various mechanisms. So max pooling, min pooling, like that. It will just reduce the dimension of that. Okay, so people are using this. Everybody knows that one major advantage of convolution neural network is that you can give raw data to convolution neural network. You don't need to extract features. The convolution layer itself will extract features depending upon the problem. It will extract, depending on the problem and the data, it will extract features, and then the extracted features will be fed to the fully connected layer to perform the classification. So this is extremely popular. There are very popular type of CNNs available in the internet, and many research groups have come up with very popular convolution neural network examples. Okay, now unsupervised learning. As I mentioned that in case of unsupervised, you don't need any type of labels. Okay, okay, I have only 2 minutes left. So this is one very popular method of unsupervised learning is autoencoder. Okay, this is the primary aim of autoencoder is to produce the output which is exactly same as the input. Okay, so I'll apply some data point at the input and the output should be exactly the same data point, exactly the same values which are output should be exactly same as input. So in case of autoencoder, this is our cost function. Okay, so xi is the input and x dash I is the outputs. Okay, our job is to, our cost function is the MSE between the input and output, and our job is to minimize this difference between input and output and find out the corresponding weight values. Okay. So this first block is known as encoder, and the second block is known as decoder. Okay. And there is sparse autoencoder. I don't have time. Okay, so this is the application. So in our lab, we have done we used to do photoacoustic imaging. Photoacoustic is a special type of imaging where the input is light and the output is sound. So the soft tissues are being irradiated by laser light, and these laser light are being absorbed by the tissues, and then the certain portion of the tissues get heated up, and some pressures are built up at the certain portions, and these pressures are released in the form of high frequency sound waves or ultrasound waves which are detected. Okay, so again, these are different types of image. You will probably hear this type of image if you are associated with medical imaging. You are probably familiar with A-line images. This is A-line. This is B-scan image. This is C-scan image. I wanted to explain what are those, but I don't have time, so I'll show the example. And these are some results. Okay, so this is we performed actually one ex vivo study with actual human patients of prostate cancer were performed in our lab in University of Rochester. Okay, so this is the photograph of the ex vivo prostate cancer, and this is the histopathological slide, and the radiologist, he has identified this region as the cancer region and this region as the normal region. These are the photoacoustic images acquired at different wavelengths, and we have identified that these blue regions are the regions of the cancer, and the white region are the region corresponding to normal. Okay. Now the classification matrix, this again I wanted to mention. So this is the confusion matrix. Okay, this is the confusion matrix formed by predicted class and actual class, and you'll just see here when my actual class is actual class is malignant, and my classifier also predicts as malignant. This is known as true positive, and others are also like that. So here, I just want to mention here, this is very basic, so probably all of you are familiar with that, but I just want to mention that I always, which one type of, so true positive and true negative, they are desired outputs, but false positive and false negative, they are errors. Okay, so which type of error I want to avoid? I want to avoid false negative. Okay, so false negative, I do not want my prediction. Hello. Okay. Okay. So I want to avoid this false negative type of error. Okay, so we performed SVM using scikit-learn, and this is the result of SVM. Okay, so this is the so we performed after SVM we achieved sensitivity of 0.84 and specificity of 0.91, and accuracy was 0.88. Okay, so SVM, again for this SVM we wanted to classify between cancer and normal, and these are the results of ANN. So ANN results are quite good. we achieved sensitivity 93% sensitivity, 91% specificity, and 91% accuracy. Area under ROC is quite high, 99.99. Okay, so we did some, okay, so we extracted different types of features. So one type of feature is multi-wavelength photoacoustic, multi-wavelength PA pixels, then another type is chromophore concentration, and then there is combination of PA pixel and chromophore concentration, and then there is frequency parameters. And we perform classification with each type of feature. I don't have the time to go into detail. What I need to mention, what I want to mention, recently we have done one study. So these are the handpicked features. So whatever we have mentioned here, these for concentration, for PA pixels, these are all handpicked features. So recently we want to compare between handpicked features and automatically detected features using CNN. Okay, so we trained a CNN. Okay, we trained a CNN which can automatically detect the features. Okay, and then at the output of the convolution layer, whatever we have obtained at the output of the convolution layer, using those as features, we perform some normal class. We use those features with some normal classifiers like SVM, RNA, SVM and RF. Okay, so here we have compared the performance of performance of actual raw data, classifiers with actual raw data, and classifiers with handpicked features, classifiers with automatically detected features by CNN. And you'll see that in most of the cases, the automatically detected features, they are performing better than the handpicked features or raw data. Okay, and another thing we wanted to do, we wanted to perform unsupervised classification using a specific type of autoencoder, and we wanted to compare the results of unsupervised classification with some normal classifiers, normal clustering algorithms. So we compared the results of autoencoder with k-means and PCA, combination of PCA and k-means, and we see here that autoencoder with k-means, they are providing, no, so the normal autoencoder, they are providing the highest accuracy. Okay, so again, the references for the majorly I have used books by Christopher Bishop for this, and then there are various publications of Dogra Lab. If you are interested, you can always go visit Dogra Lab, which is a lab formed in University of Rochester Medical Center, University of Rochester, where I did my PhD work. Okay, so you are welcome to visit that. Okay, so that's all. This is my talk. I think, yeah, I have already exhausted all the time given. Okay, so that's all. So I'm going to stop here. Yes. I don't know whether I can take any questions or not. I don't think that there is enough time, but still I am going to hand over to organizers. Yes, madam.
Thank you, sir.
Yeah.
If there are one or two questions, we can take, but time won't permit us for more than that.
Yes, I understand.
So let us see if anybody wants to post one or two questions. We can take those questions, and then we have to proceed further with our
Yes, madam.
So if anybody have any questions, please put in the chat box over here or on the YouTube video. I'm watching that, and if questions are there, I can forward it to sir.
Yes, obviously.
I think you were very clear on whatever you have discussed actually.
Okay.
You have taken things in very detail. So
yes,
things were very clear to everyone. So the question of having doubts is very less in this particular session actually.
That I don't know. Okay, but
yeah. But let us wait for 1 or 2 minutes more.
Okay. Okay, if there is no question right now, you can share my email ID, my Gmail ID with the participants, and if they want to further ask me any questions, or if they want to do any kind of collaboration or something like that, I am always open to that. Okay, so please share them my Gmail ID. They can all contact me via email.
Okay, sir. Definitely, I will do that. I will put your Gmail ID on the groups
Yes.
which we have created.
Okay.
And,
Okay. Okay. Okay.
so thank you very much, sir, for
Yeah.
such an informative session.
Okay.
And such a lot of information was there in the session. It was information packed, and we learned a lot from all the concepts which you have delivered over here, and understood the research which you are doing, which is a practical research which you are doing. Thanks a lot for such a wonderful session.
Yes. Yes. Thank you. Thank you,
And-
madam. Thank you. Thank you.
Okay, sir. Thank you. So participants, we are done for our fourth session. We'll be joining back at 1 o'clock for the last session of this FDP. And thanks all of you for being patient listener and wonderful teams to work to have the FDP with. Thank you all. So waiting for seeing you on 1 p.m. for the last session. Thank you, everyone.
मैडम स्टॉप कर सकते हैं?
Yes, sir.
थैंक यू मैम.
We are done with the session. Thank you all, everyone.